So yesterday we talked about long division. As I said yesterday, long division is just like your old long division back in your elementary school, okay? So it's not anything really different. You still utilize the same concept. You want to cancel the first digit, and then you just think about what you multiply, okay? Now, one thing that I want to emphasize today is this. Now, yesterday I talked about how there could be possibility of missing terms. Now, something like this could be very obvious because you look at the power, you're like, oh, okay, this is x to the fourth power. So let's go. And then right after x to the fourth power, you're like, wait, hold on. Are we missing something? Okay, so it's very obvious that you can spot out the fact that, hey, we are missing x to the third power and x squared. Now, something that you want to learn from other people so that you don't get hurt is this. What is your default setting? Your default setting is that always assume that it could have a missing term. All right, your default should not be like, oh, there's everything is good, right? There's no missing term. No, the opposite. Your default should be that you always assume that it could miss a term or two. And when you do that, it protects you. So for example, here we're saying, oh yeah, it's missing a couple of terms right here. So we need to fill them out when we do long division, okay? Make sure you fill them out when we do long division. So we say, all right, so all we need to do is to perform this long division to obtain our quotient. And maybe there's a remainder. So we would say x to the fourth plus 0x cubed plus 0x squared minus 13x minus 39x minus 3. Okay, so we do that. And then we say, all right, what do we multiply with x so that we can cancel out the x to the fourth? And that's a very obvious x cubed. And like I said yesterday, I want to remind everybody that make sure that you write down the minus. And for what I would do, I would go ahead and put the minus with a circle. Now, some teachers out there, they might suggest another thing, which is that you go ahead and change the signs right away. Not that it's a bad idea. For me, I mean, if it's a minus like this, that's fine. You can change it to a plus very easily. But the thing is, I like to keep it the original way. I would just process it for one. Number two is that what if it's a plus? Then I have to change the plus to a minus. I have to take out my eraser. It's just too much work. So I'm just gonna run through my subtraction every single time without changing any signs in the middle. And then we bring down the second term right here. So we have plus 3x squared. So we have 3x cubed minus 9x squared. Okay. So what do we bring down next? What would it be over here in the highlighted area here? What do we write? We write down 9x squared, not minus 9x. There's no minus anymore because it's a subtraction of a negative entity. Okay. So 9x squared minus 13x, and then plus 9x. So 9x squared minus 27x. Yes. You subtract again. And then you've got 14x. Positive 14x, and bring down the 39, and then you have a plus 14. So 14x 14 times 3 will be negative 42. Have a little bit more room. So so with this experience, you know that you want to write in with the proper font. You don't want to write too big because you may run out of space. And this is a subtraction, so your remainder is 3. Okay, your remainder is 3. Okay, so what you can do is to present your answer. Your answer is x cubed plus 3x squared plus 9x plus 14 plus 3 over x minus 3. Okay, so that's the using long division to perform the division here. Yes. Mm-hmm. It will be a positive because it's a subtraction of a negative number. So again, you can see this all the time. And yes, it is very tempting. So that's why you got to practice. You got to practice to make your mind accustomed to this thought process. Okay, you know what is out there in the trenches. Like same thing right here. This is a minus with a negative. Okay, so that's why it's positive 9x squared. Okay, so so whenever you see a minus, or actually whether it's a minus or plus, just take some good special care, and that will be the challenge of this long division. I have to admit. Now, then you look at the next question. Right down below, it says, is x minus 3 a factor of x to the 4th minus 13x minus 39? And we will be nodding or shaking our head. We'll be saying, no, why not? There's a remainder, right? So so we say no because there is a remainder. If it's a factor, there shouldn't be a remainder. Because there's a remainder, so it would not be a factor. So we're going to see this quite a bit. Okay. So again, something that that it took some time to kick in my mind is the understanding of what a factor is and how it relates to what we did back in elementary school or middle school. If it's a factor, the remainder should be 0. Okay. If it's a factor, there should be no remainder. Okay. And in other words, if there's a remainder, it is not a factor. Okay. Learn how to say it. Okay. Learn how to say it. And it takes time. It takes time to kick in. I hope you can understand this meaning faster than I did when I was a kid. Okay.